Hello everyone, till now we have gone through half adder and full adder. In this video we will understand about ripple carry adder, why it is named as ripple carry and how we are making a ripple carry adder and what is the use of it. So let's begin with the ripple carry adder. We will utilize both full adder and half adder concept to make this. What is ripple? You might be knowing that ripple means dropping, like it is just a normal English term. Ripple means rippling effect, jumping from one position to next, to next, to next, to next. So, what does this means? Our carry is jumping from first position to the second position to the third position to the fourth position. Like it is moving from the least significant bit to most significant bit, rippling from um, lowermost to uppermost like this. So this is all about the ripple carry adder. Let me remove this. It is just a simple explanation thing. Now let's see. Suppose this time I am not taking any means any binary number. Instead, I will be taking, suppose a binary number is a, which is being represented by A0, A1, A2 and A3. This A1, A2, this A3 can be like 1, 1, 0, 1. So this can be A0, A1, A2, A3 like this. And our second binary number like B3, B2, B1 and B0. Suppose these are two numbers. So how carry is been moving when we do an addition, binary addition? So let's write it like A3, A2, A1 and A0. And here it is B3, B2, B1 and B0. So how we are going to add it? So suppose A0 plus B0 binary addition is giving us some result as 0 and is giving a carry as C1. Now we have three number A1, B1 and C1. Suppose these all sum are coming to be as 1 and our next carry is rippling to C2. Means the carry was here and we sum it and the next carry is forwarded to the third most bit. So now its sum is S2 and we are moving C3. Its sum is S3 and if there is some carry we will be moving forward as C4 which will be moving down and directly coming as in the form of C4, or we can also term it as S4, right? So now let us see how we can create a ripple carrier adder in circuit. So you are familiar with half adder, right? Half adder is used for the sum of two bit. So instead of drawing a gate circuit, I am directly drawing a box diagram where suppose this is our half adder. Okay, half adder. I am representing it by edge for now, or HA, half adder. Let me make it slightly bigger so that HA can be fitted. HA. It will be having two input. What are those two input? A0 and B0, which is giving an output of S0 and a carry of C1, right? So now, since we are having the 3 bit, we can't utilize half adder now. So for the next addition, we will be utilizing full adder. So again, this is our full adder, and what full adder is passing? Full adder is passing with the C1 and A1 and B1, right? And it will be giving us sum as S1 and carry as C2, right? Now again this C2 will be passed to another full adder because there will be again 3 bit sum. So this is FA and this is A2 and B2, like this. And for the last, let me put slightly side, and again this will give us S2 and C3, right? This C3 will be again passing to a full adder, which will be utilizing C3, A3 and B3 as input. Got it? Now what is remaining? Only C4 is remaining. So this will be giving us sum as S3 and a carry as C4, which can be further written as S4. So what is our answer like? We will be reading from this side to this side. So S0, S1, S2, S3 and S4 will be our final added value. So here we are utilizing 1, 2 and 3 full adder and one half adder. So one question might be coming: how many AND gate and how many OR gate and how many XOR gate are required to build this circuit? So we know that for a half adder we need one XOR, let me write like XOR and AND gate. Let me write it more clearly so that you can also note it down. Changing the color. Suppose this is our full adder or half adder gate, like I will be writing gate. So XOR gate, AND gate and OR gate. So let's write how many number we are requiring. So for a half adder we require XOR as 1 and AND gate as 1. We don't need XOR gate, right? For full adder we need XOR as 2, AND as 2 and OR gate as 1. So from this you can easily know that how many gate we need. There are three full adder. So how many XOR gate required for three full adder? So 3 2 jar 6, 6 and this is 3 and one half adder 1 1 and 0. So how many gate are required? 6 1 7 6 1 7 14 15 16 17 gate are required. Oh, I'm sorry. Yeah, 17 gates are required in total. So, in this way, you can calculate how many gates are required. Uh, Now, can we utilize the same thing and without utilizing the half adder, can we make it entirely with the full adder? Let's see. So, instead of, let me show you, here we are utilizing half adder. Instead of using this half adder, can we just replace this particular half adder with the full adder? Definitely we can replace it because half adder can also sum two value while full adder can also sum two value, means it can sum the 3 bit, so it can definitely sum the 2 bit also. So we will be just making it like this and we will changing it to full adder and adding a separate C carrier flag which will be initial to 0, which will be initiated to 0. Rest all will be the same thing. So it is just a simple addition of full adder, but rest all the means thing will be same. But it will affect the count here. Now instead of 17 gate we will be utilizing how much? There are 4 full adder are there. So 8 plus 8 plus 4. So we will be utilizing 3 additional gate if we are considering to not use half adder and we are considering to use only full adder, then we required 3 additional gate. So from here you can simply know that how we decide that we want to use only full adder or we want to use the combination of half adder, right? So it all depends upon how optimal your circuit is, how you can optimize your circuit, how you can means simplify your circuit. So in the next video, we will be generally describing about the circuit simplification process, means whole circuit simplification using the Boolean algebra or using the different k-mean method, or there are many methods where we can use to simplify our circuit diagram. So what is happening, why we need to simplify our circuit? Because we know that each gate cost us something, right? Each gate is related with some cost, and if we can optimize our circuit we can reduce our circuit, and if the circuit is giving us same output for the same input, so we will try to minimize our cost. So that is why we need circuit simplification process. So in the next video I will be talking about that, but we are also going to look at the ripple carry vector implementation, means ripple carry adder implementation in Python. So let's move to the Python online compiler where we will discuss about the coding of ripple carry adder. This is the Python online compiler. So I will be sharing the link with you and you can code as well. So let's start our coding portion. So first we will check whether our cell is working fine and our editor is working fine. So yeah, it is printing hello world. So let's just remove this and start our coding. So as you see in the diagram itself that we are utilizing how many full adder we are utilizing 4 full adder. Or you can say 1/2 adder and 3 full adder, but in this code I will be using entirely full adder because it is just simple code and we are not utilizing actual gate and it is not related with any cost or something like that, so we can utilize all the 4 full adder. So can we just start with whatever things we need? First of all, as you know that we need some input bit, right? Input, uh, for simplicity, let's write like this. Some input A and B, which will be in the form this like this 111 or 1010 like this, right? So we have to add these two binary number. So can we start with just making the full adder first, then moving to the ripple? Because in the ripple carry adder, we have to utilize the full adder. So can we create a function with full adder? Because in the last video we have already created. So let's quickly create our full adder so that we can utilize that particular function. So it will be consisting of input A, input or directly writing, or should I write the same syntax? Okay, it will be quicker. Input B and one carry, right? And our sum will be input A and input B. Next, our carry. What will be our carry? Carry 1 will be input A and input B. And our sum out will be sum 1 and C input. As per the diagram of full adder, means we have coded it last time, so you might be aware of this. And our carry 2 will be sum of 1 and C in, right? And our final carry means C out. What will be C out? Our C out will be carry 1 or carry 2, and simply we will be returning our sum out as well as C out like this. Okay, so now we will create our ripple carry adder. So let's create a function ripple carry adder. So what it will be taking? It will be taking A and B. Now since we will be passing it in the form of list, for simplicity we will be passing it in the form of list. Suppose 1 1 0 1, this is our A, which is simply which is simply 1 0 1. Our B will be 1 0 0 1, which is simply 1 0 0 1. Okay, so let's create our ripple carry adder. So from the figure itself you might be knowing that if our length is 4, then we will be utilizing how many full adder? We will be utilizing 4 full adder, right? So we will be calling our full adder how many times? 4 times. So simply what you can do, you can use the first thing you will calculate is length. What is the length of A or length of B? Because we know both should be same, so we can either create the means either count the length of A or length of B. Now we will be moving in the backward direction, means from rightmost to the leftmost direction. So we have to calculate on the first this rightmost bit, right? So for that we will be running our loop from from rightmost to the leftmost. So we know Python is indexing from 0. So our the first bit if we want, so what will be the index of the first bit? 0 1 2 and 3. Since length will be 4, so it will be n minus 1, right? Now till when we want to run the loop, we want to run the loop till it end here, right? So 3, then 2, then 1, then 0. So we know that Python exclude the last one. If we are putting -1, so it will be running till 0, and we will be decrement it by -1. So now before running the loop we should be also doing one thing. Since we know that our initial carry will be 0, because we know that first we don't have any carry. Now we want to store our result to something. So our result will be stored in this result variable. So we have to initialize the result variable. So what this do? Like how many bit we want to store in result? From the circuit itself you are seeing that we are getting an extra carry C4, which is utilized as S4. So how many bit we want? We want 5 bit. Since we know that length of n is 4, so for 5 we can do n plus 1. Now let's call our full adder function. So let's start storing our result. Result of I means last, it will so what this will create, this will create like this 0 0 0 0 and 0, 5 zeros in a list. So our result I will be the last bit, right? Last one. So uh, since we want to store it in our last one, so what we can do, we can just write it like I plus 1, because we want to store it here, and where it is at the last fifth position, means 0 1 2 3 and 4. Since we know that I is 3, so we have to add 1 to get here to modify this particular bit. So result I plus 1 equal to what it will be. So first thing, this will be some result I plus 1, and there will be another carry, which is this, right? We will be changing this carry accordingly, right? So is equal to, what will be, it will be full adder, right? And what we will be passing in full adder, we will be passing in full adder a I comma b I comma carry. Mind this carry will be changing every time, and this carry will be updating. If you are aware of Python, so you might be knowing this thing. Now this is all thing, this will run and our carry will be forwarded and everything will be happening here. Now we want to update our last bit. Last means after all the four for loop got run, our last carry should be moving to some places, right? So let's, before writing that, let's check whether what we are getting, as a result. So if we calculate, oh sorry, it is not returning anything. So first let's return, what we will return, we will return result and carry, right? So let's see sum out ripple carry adder, right? And we also want to print input A and input B, so that we can just check it in the cell itself. So print input, no sorry, print A and print B, or you can modify like input A, okay, or you can put a space. It's all on you how you want to write your code beautifully. And it is B. So now this is all. Now we are calling our ripple carry function here, ripple carry adder function, and we will be passing a comma b, which we have already initialized here. So let's see if we are getting any error or is everything fine, or yeah, we have not printed anything, right? It will be sum out and carry out, right? So print sum, and sum will be what? It will be sum out. It's simply result, and print carry, which is simply carry here, right? So let's check how we are performing, how we are seeing it. So let me run this code, and what it is saying, name carry is not defined. Oh, here it is carry out, not carry. So now we will run again. Okay, so here if you see what is going on, sum and carry, right? If we want to have only final sum with sum is equal to like we want to include this carry in this sum, so for that we have to include here, right? Since this loop is running till this position only, it is not updating this, so we have to externally update this carry here. For simplicity, let's check 1 1 0, carry 1, 1 plus 0 1, and this 1 plus 0, no, there was no carry, then 1 plus 0 is 1, 1 plus 1 is 0, and carry is 1, but this carry is not updated here. So what we can do, we can simply update result. First result of 0 is equal to carry, right? So now this first will also get updated, and if we run the code, and here you will see this is our final sum, right? And this carry is, you can ignore this carry because we have already included it in this sum, right? This is the ripple carry adder. So with this, I think you have understand how we can use full adder to create ripple carry adder. So this was, I know this was more of coding video rather than more of explanation video, because ripple carry adder is just a simple topic. In the next video we will be talking about the simplification process of various gate. Means I have told you already why we need to simplify a circuit, because all circuit consist of some cost, and we want to minimize those costs, so we have to simplify this circuit. So I will see you in the next video. But if you like the video and get some knowledge from this video, do like. If you want to motivate me, do subscribe to this channel. If you have not get anything from this video, or you did not like this video, you can just press the thumb down button and also comment down what improvement you want in my channel. With this, thank you, goodbye.